Hello everybody, hello, and welcome back to the Flare Educate series. This is week 3 of the series or session number 5. In week 1, we kind of started with a general overview of what blockchain is, or what smart contracts are, or what EVM is. And then last week, we finally turned to Flare and how Flare operates as a protocol. Today, we are continuing the session number 5, as I said, with FDC and FSP. FDC is the Flare data connector, and FSP is the Flare systems protocol. I'm sure you've heard those acronyms already before. If you were here last week, you definitely heard about them. But today we'll be diving into more detail into them and seeing what exactly they are and how they work, and of course how they can help you build your own projects with Flare. Today, Anthony from Flare is with us once again for FDC and FSP. So without further ado, Anthony, the floor is yours. Good luck.
Thank you, Nevin. So like Nevin was saying in the introduction there, we did cover a good amount of ground here. We went from the basics, the concepts and fundamentals of blockchains and what decentralization means, consensus mechanisms, tokens, Oracle smart contracts, EVMs, how to get started. A lot of things that are core to understanding blockchains. We talked about the FTSO. Now today we're going to discuss what exactly the Flare systems protocol is and talk more about FDC. Now a bit of a caveat here, maybe the ordering, I think the ordering could have been a little better. That's okay, because the Flare systems protocol, what it does is that it enables the Flare network to have the FTSO, to have the Flare data connector, which we're going to talk about today. Okay, so just keep that in mind as we're going through the presentation here, and I'll give you a quick roadmap here of how it's going to look. We're going to look a bit deeper into what I'm talking about now about the FSP, the Flare Systems Protocol, what the Flare Data Connector is, and then to make it a bit more interactive, we're going to do what we did with the FTSO protocol and run through an example that you can find on the Dev Hub that I shared with you in the last presentation. And to do that, let's talk a bit about a state connector problem. Getting a little bit ahead of myself, but that's okay. With the state connector, or the problem here is that we don't have access. You have to remember that the blockchains are isolated environments. Okay, the smart contracts, by their very nature, they can't directly and trustlessly verify information that originates from other blockchains or from off-chain systems. Okay, but if you want to build truly interoperable and data-rich smart contracts, you need a way to trustlessly verify external state, and that's a core challenge that I don't think any other blockchain network has focused on. So how can we securely and trustlessly prove the state of another system, whether it's another blockchain, a Web2 API, or any other data source on our own blockchain? For example, how can a smart contract on Flare trustlessly verify that a specific transaction occurred on Bitcoin, or that a particular piece of data from a website is accurate and hasn't been tampered with? These are some of the things that FDC allows, and we'll talk a bit more of how that actually happens through the use or the creation of the Flare systems protocol. Remember in the beginning, I said that the FSP is enabling these protocols to exist, the Flare data connector and the FTSO. So the Flare systems protocol, it's a core foundational protocol on the Flare network that's designed to solve bringing this data on chain. Some of you had questions about the voting and the delegating, etc. We're gonna talk about more about that today. And the idea, it is designed to enable the trustless, decentralized, and scalable verification of state from any open system. And there are some limitations on FTC right now. I believe today, February 3rd, we're launching on mainnet. We're about to launch on mainnet for FDC, and we'll talk about the data sources that you can use on FTC a bit later. But there are some limitations with it, but that I'll go into when we get to the example. So the FSP is providing a secure and an efficient data attestation mechanism. You can think of it uh, like creating a cryptographic certificate of authenticity for external information, allowing it to be reliably used on chain. And it's important to understand that FSP it's an independent protocol. While it is used by the Flare data connector, it's broadly applicable. So it's the FTC is using it, and the FTSO is using it. And here's a bit about the architecture. You don't have to know this specifically for uh, building your own project, but it's important to keep in mind because some of you had questions about the architecture of the Flare, how Flare works and how it enables the data to be brought on chain. So the process begins with proposers, and these are entities that want to verify some piece of external state on Flare. And they initiate the process by submitting state claims, essentially asserting that something is true or false about an external system. And they also submit the associated cryptographic proofs alongside their claims. Okay. A decentralized voter network composed of independent validators then takes over. These voters are responsible for verifying the cryptographic proofs provided by the proposers. The core of FSP, though, it lies in the attestation process. Voters examine these proofs, these cryptographic proofs, to independently verify the validity of the state. And they can do this without needing to trust the proposer at all, which because it's relying on the cryptographic proofs. And to enhance the security and decentralization, FSP often uses the threshold signature scheme for a secure distributed key management, I believe, during the verification process. And then once a claim is verified through the voter consensus and cryptographic validation, a valid attestation is recorded on the Flare blockchain. And this on-chain attestation process creates a trustless and auditable record of the verified external state, which can then be reliably used on smart contracts. Okay, and it's a lot to take in all at once, and that's why I'm going to direct you towards the docs after this. But it's important to get at least a general and high level overview of it. So this goes a bit deeper into the key features of FSP. And first, is a claim submission process. So proposers initiate the process by submitting their state claims and the cryptographic proofs of the FSP smart contracts. The verification phase, you go through verifying the proof, the voting phase, the consensus phase, the attestation recording phase. This attestation makes the verified external state available for use by smart contracts in a trustless manner. It's also important to note that the FSP protocol incorporates sophisticated incentive and slashing mechanisms, which that's going to ensure the ongoing honesty and reliability of the voters. So that's where you get this economic security from these protocols. And so some use cases, like I mentioned before, the FSP is allowing or enabling this this cross-chain interoperability, okay, enabling the creation of secure and trustless bridges between different blockchains. So for example, FSP can be used to trustlessly verify cross-chain transactions, ensuring that assets moved between blockchains are properly accounted for. It also includes secure data verification for decentralized applications. Dapps can use FSP to trustlessly verify data from Web 2 APIs or other off-chain sources. Um, and for, I mean, a quick example is it can also be used for decentralized identity verification solutions that require verifying credentials or information from external identity providers. Okay, and with this, you can create this, smart contracts that have access to richer data. So we talked about FTSO uh, in the last presentation and how it's getting decentralized price feeds. The Flare systems protocol is what enables that to happen. And another thing that it enables is the Flare um, data connector. And as I mentioned previously, the FTC uses FSP to provide a user-friendly way to access trustlessly verified data. Okay, so it simplifies the FSP for you. You don't have to understand the Flare systems protocol that much because we're going to go through an example for FTC because we offer a developer-friendly interface that you can use. Okay, so let's instead of I'll actually read this here because I'm talking about the FTC in relation to FSP. So it allows this user-friendly access to verified off-chain data. I'm including the definition right here, which you'll see in our docs. And I'll just read that for you. The FTC is an enshrined oracle designed to validate external data for Flare's EVM state. Okay. It allows to submit attested data that smart contracts can trust, eliminating the need for direct reliance on users for data integrity. Okay. And now we're going to go through this example here on FDC. So I'll share this with you first. I'll put this in the chat. So if you'd like, you can follow along with where I am here. Before we go into FDC, I'm gonna show you around the docs first. If you want to get to this tab, you just hit the network tab and click on the Flare Systems Protocol. And this is going to talk about all the technical things that you want to know about, the key features, how it enables the FTSO and FDC enshrined oracles to work. This is a good graphic for you to understand. You have the Flare blockchain, then the Flare systems protocol, and then the enshrined data protocols with FTSO and FDC. And this is where you can find all the information on FTSO. Okay, so let's go through an example here. But first, this is the FTC docs. It'll talk about the high level here, gives you some charts here, the data availability layer, which we can talk about a bit later, the workflow, some of which I shared with you already. So let's go through a quick example here. Okay. And this example, let me just make sure I'm on the right page here. Okay. So this example, the goal here is to demonstrate how to use FTC to verify a transaction that occurred on I think the Ethereum Sepolia testnet from a smart contract running on Flare. Okay. And specifically, we'll take an existing transaction on Sepolia, verify its details using FTC, and then decode an event log contained with that transaction in our Flare smart contract. Okay, and we'll follow a series of steps here, and this is where we're starting right here. If you go to number 1, identifying the transaction, that's where you'll that's where we're starting. So the first step is to identify the specific transaction on the Sepolia testnet that you want to verify. Okay, and for this example, we're using a transaction here that's already been minted and confirmed with this hash. And as you can see in the if you go to the block explorer, the transaction exists. It's already been mined and confirmed. Okay, and these events will be what we want to decode and use in the Flare smart contract to demonstrate FDC's capabilities. Okay. It's important to note that if you're using it in a real world decentralized application, you wouldn't manually pick a transaction hash like this. Instead, you would programmatically identify the transaction you want to attest to based on user actions, specific events, or other application specific criteria. But for this is obviously an example that we're going to use, so we don't have to do it programmatically. Okay, so now that you have your target transaction, the next step is to prepare the attestation request. And to easily do this, we'll use Flare's provided verifier API service. Okay, you can click on this to see this. I believe you can still use this. And this is a way, the verifier API provides a convenient way to encode the details of our attestation request in the format that FDC needs to understand. Okay, and that's the endpoint you're going to use is I think the /verifier /ETH/EVM transaction /prepare request. And that's specifically designed for EVM transaction attestations. And this is what the JSON object looks like when you're creating this request. So you have the attestation type, which specifies that we're requesting an EVM transaction attestation for this specific example. You have the source ID here, which it's set to test ETH to indicate that we are testing to a transaction on the Ethereum Sepolia test network. And within the request body here, we provide the transaction hash of the Sepolia transaction we identified in the previous step. And we also set the required confirmations to one here, the provide input and list events to true, and then we leave the log indices empty to get all events. And the verifier API, upon receiving this request, it will return a JSON response containing the ABI the ABI encode request. Okay, and the ABI encode request is the encoded representation of our attestation request, which we'll use in the subsequent steps to interact with the FDC smart contracts. Okay, and here's the code for everything that I just mentioned to you. So with the ABI encode request prepared, we now need to submit this request to the Flare data connector smart contract, specifically the FDC hub contract. And this broadcasts our attestation request to the Flare network and initiates the FDC attestation process. And we do this by calling the request attestation function on the FDC hub contract, providing the ABI encode request as the input. Here's the code for what I just mentioned there. This is the FDC hub address. You're submitting the request, requesting the data, okay, getting the contract, then request the attestation with the ABI encode request. Okay, Remember, that's the response that you're getting when you're sending your attestation. And just as an example here, we're using Ethers, the Ethers library, to interact with the smart contract. Okay, and then after submitting the transaction, we obtain the round ID from the transaction receipt. And this round ID is important because it identifies a specific FTC round in which our attestation request will be processed and where the Merkle root containing our attestation will be stored. Okay. And you can even use a block explorer to view the transaction that submitted the attestation request to the FDC Hub contract. And that's how this flow would work. Okay, so this is submitting the request to the FDC Hub. So once your attestation request is submitted, the FDC consensus process is complete for the relevant round, and we can extract the Merkle proof and the full data for our request. And to do this, we're using the Flare data availability layer API, the Flare DA layer, and the endpoint for this, I'll send it to you later. And there's more information on the docs on the Flare DA layer here, which you can read up on. But it's a layer that the FTC is using to process these requests. So the request body for this endpoint is also in JSON format. We need to provide two key pieces of information, which are, you can find here, the voting round ID, what we attained in the previous step, and the request bytes, which is our original API encode request. The DA layer API will then respond with a JSON object containing two fields: the proof, which is the Merkle proof itself, and the response, which contains the full data about the attested transaction. And this response includes all the details, including the event logs that we're interested in. So the proof here, I should go down here. So the retrieved proof and response are what we will now use in a smart contract to verify the data and extract the event information. Okay, so here's a full proof that you can look at: attestation type, voting round ID, the events, and the proof here, which is the Merkle proof. Okay, so how do you actually use this data in a smart contract? So this is a step where we use the verified data in a smart contract, and we'll deploy and interact with a simple smart contract here, which is the transfer event listener. If I go to that contract, yeah, transfer event listener. And this contract, it contains the logic to verify the Merkle proof and extract the event data that I just showed you. Okay. Where is it? There's a function defined here. Yeah, the is EVM transaction proof valid function. This is a crucial function here. It's using a library provided by Flare to verify the proof, the Merkle proof, against the provided transaction data. And this verification step, what it allows is that it ensures that the data that we received from the DA layer API is indeed the data that was attested to by the FTC and hasn't been tampered with. Okay, and the core business logic is in the collect transfer events function. So first, it's a calling the is EVM transaction proof valid to verify the proof. Then it iterates through the events array. Remember, I showed you all the events there. As it iterate through all of them, within the response body. And then this is the event log data we retrieved from the DA layer API. The contract would then filter for transfer events specifically emitted by the USDC contract on Sepolia. And for matching transfer event, for each matching transfer event, it decodes the event topics and data to extract the sender, receiver, and transferred value. And then finally, it stores this extracted transfer information in the token transfers array within the contract. And the get token transfers function is a simple getter function that allows us to retrieve the list of token transfers that the contract has recorded. And this example demonstrates how you can use FDC to not only verify data from another blockchain, but also to process and utilize specific information within that verified data in your smart contract. Okay. So again, that's I don't expect you to fully understand everything that I talked about today. And that's why you should run through this example, run through this page a few times to fully understand what's actually happening. This is basically getting an event or transaction that happened on another chain. In this case, it was the Ethereum Sepolia testnet, and then bringing that on to the Flare network using FDC. And then to get it into smart contract, we listened to that transaction. We verified it with this function here. This is an very important function. And then ran through all the events that we received from the DA layer. And if I go up back to the response body that we got from the DA layer, these are all the events that it's going through to find the specific transaction. Then the proof to verify that that data has not been tampered with, altered with in any way, shape, or form. So hopefully that gives you an overview of the FTC. There's a bonus at the bottom here. You can read through that if you'd like. And the Flare Systems Protocol is here for you as well to read through and get a fundamental understanding of how that enables the FTSO and FDC. And I think that's a good place to stop for any questions that anybody might have about FTSO, FTC, or even going back to FTSO.
Yeah, we already have a couple of questions piled up in the questions tab. If anybody else wants to ask the questions, you can do so now, again, in the questions tab or in the chat. So first up, there's a question from Deepak asking which chains is Flare compatible with, and big ones that it's not compatible with yet, but that are in the pipeline right now.
Yeah, so for the chains that FDC is compatible with, I believe it's Bitcoin, Ethereum, Doge, and XRP right now. Those are the four main ones. I'm going through the reference right now. I should have it listed. But yeah, those are the four right now to answer your question.
Yeah, very good. Next up from Michelle. I'm sorry if I'm butchering your name. Do you plan on adding any further sub protocols to FSP aside from FTSO and FDC?
We don't. I mean, I don't want to comment specifically on that, but we do have something that you can read up on called F assets. Okay, and because we have FTSO and FDC, one thing that F assets does is actually, instead of bringing all the transaction data, we can actually bring on the assets of other chains. So we could, if you have Bitcoin, instead of using a bridge that's, a wormhole hack and a lot of other hacks, this is a trustless and decentralized way to bring on your Bitcoin to the Flare network. So that's not specifically a sub protocol, but that's what the two sub protocols allow.
Nice, very, very cool. Also from Michelle, also, can you go a bit deeper into FSP's features like voting and signing?
So if you go to the tab here and go to the components, this will go into all the specifics about voting. Okay, if I touched on everything related to voting, I think it would confuse a lot of people. Not confuse people, it'll just take a long time to digest it. And I think if you really want to get a deeper understanding, you should read this on your own and go through and understand the voting if you'd like. It's not necessarily required for you to start building, but this contains all the information you'd ever want to know about the voters, the voting results and finalization, signing policies, is the weight participation of these. This is where you would go to answer all your questions.
All right, very, very nice. Up next, a question from Russell. What are FDC attestation types?
Okay, so this is a good question. So, and this is something I didn't talk about specifically, but the attestation types are right here. These are the 6 attestation types we have right now. We plan to add a lot more to them over time. And what I shared with you through the example is the EVM transaction. So we verified that an EVM transaction happened on the Ethereum Sepolia testnet. We can also attest whether an address is valid or not, confirmed block height exists, payment, if a certain payment was made on another chain, if a payment didn't exist on another chain, balance a decreasing transaction. And these are the 6 attestation types that we have right now. So it can do non-payment verification and event log authentication.
Very cool. Any other questions right now? Let's give it a couple of seconds. Maybe somebody else can think up of something. What's happening next Wednesday? Philip, our next speaker for the Educate series, will be diving into those. But before we do that, we'll be having 2 sessions more on FDC specifically, where Philip will be taking a deep dive into FDC and its various components. So yeah, in other words, this is Anthony's last session for now. Philip will be taking over from this Wednesday onwards for the final 3 sessions. So Anthony, any final words before Philip takes over next time?
I just want to say thanks to everybody. I really enjoyed giving you an overview of this space. I hope you enjoyed it. You got some value out of it, and you built something really interesting and unique. Because I really do believe Flare is this. It changes the conversation on what blockchains can allow by giving it the rich data sources. And this is the most. If you look at all the Flare protocols, FTSO, FTC, FS, this is the most basic that it'll get. Over time, we already have some of the attestation types. Over time, we're going to add more and more functionality to make the network more and more powerful, and that's what's so exciting about Flare. So thank you all for paying attention. Thank you, Nevin, for setting all this up, and have fun building on Flare.
Yeah, I couldn't agree more. Have fun building on Flare. This is it from Anthony, and see you for FDC Deep Dive Part 1 with Philip on Wednesday at the same time. Until then, have a lovely rest of your day and see you around. Bye, everybody.